Greetings, my name is David, and I will be giving a summary of our RSS2020 paper, which is entitled A Motion Taxonomy for Manipulation Embedding. In this work, we proposed the motion taxonomy to label or classify motions that are commonly expressed through human language in a way that would make sense to a robot. Here, we focus on mechanical or physical properties, such as contact or trajectory, to describe manipulations in the form of binary strings called motion codes. From our own work on knowledge representation, we observed that it is a challenge to describe manipulations with words, as human language is inherently ambiguous. This problem also extends when we're trying to communicate the idea of motions to robots. In machine learning, motions are typically represented as vectors, which are learned using methods such as word-to-vec. However, these embeddings do not reflect mechanical characteristics of motions, and therefore, distances between these vectors do not make sense. Rather than relying on natural language, we propose that motion codes learned using our taxonomy are more suited to represent motions than word-to-vec embeddings, especially for motion recognition tasks. This taxonomy, which takes the form of a tree, describes essential properties of motion and the interaction between manipulated objects. We defined a motion taxonomy that represents the most important mechanical characteristics in manipulation motions. We consider a manipulation to be any interaction between active and passive objects, and we can describe this interaction using attributes such as interaction type, which describes whether the active and passive objects make any contact with one another, and if they do, we can describe the type of contact through engagement type, and we can note the duration of contact that happens between these objects. In addition to that, we can also note the observed trajectory of the manipulated objects in action. The key idea of this taxonomy is to allow us to obtain motion codes directly from demonstration. The pipeline to obtain these codes is as follows. Given an input demonstration video, we can use a motion classifier that is trained on the motion taxonomy to produce a motion code as output, which can then be used as features for further classification tasks. In our work, we identified a list of common household actions across several datasets, including our lab's Foon and daily interactive manipulations datasets. We then defined motion codes for said household actions. Please take a closer look at our paper for further review. Motion codes describe what happens in a demonstrated action. We can either create them by intuition, or we can obtain them directly from recorded data. We describe how techniques such as the principal components analysis can be used to extract properties that correspond to the motion taxonomy. To highlight the efficacy of motion codes, we compare them to vectors from existing word-to-vec models that are frequently used in robotics and computer vision, which include Google News, ConceptNet, and Wikipedia. In this slide, we illustrate a 2D projection of word vectors from ConceptNet, which is obtained using the TSNE algorithm. What we wish to highlight here are word vector pairings whose distances do not reflect mechanical characteristics of motion, as we would consider with the motion taxonomy. As a result, they are not ideal for class label assignment for motion recognition tasks. With motion codes and the motion taxonomy, however, we can define distance metrics that capture important mechanical characteristics. In this slide, we show a 2D projection of motion codes using the same TSNE algorithm. Here, we show how distances that prioritize contact cluster similar motions together, while dissimilar motions are further apart. In this example, we show a 2D projection of motion codes that prioritizes trajectory, and as a result, clusters of similar trajectory-type motions are formed. In short, with the motion taxonomy, we can define distance metrics that consider physical properties of motion. For a more in-depth discussion on these results, please refer to our paper. To conclude, we introduced the motion taxonomy to obtain an embedded representation of manipulation. This representation, called motion codes, can be used for motion classification tasks. We propose that they are more ideal than word-to-vec, as the losses or distances reflected by these codes make more sense with the physical characteristics of motion. Motion codes have the key advantage of being obtainable from observations of action. Thank you for your interest in our work, and please feel free to reach out to us if you have any questions or comments. Please also visit our website to read this paper and more. Thank you.